So good day everyone, and welcome to the online classes for learning the smart contract with sCrypt. So in our previous class we have write a contract that will multiply two numbers, and whoever provide the product of that two numbers is the one that can interact with the contract. So this is the contract, and today we are going to write a test for this contract. The contract name is demo, and we have two methods. One is public method and the other one is non-public method. I hope you can see my BS code and you can hear me very well.
Yes, we can hear you.
Okay, so this is how the sCrypt project is structured. Here under the source file we have contracts, where we have our smart contract file here, and under the tests we have the local test and the test net. So now we are going to start with the local test. So test is very important because before you use the smart contract in production you must always have to test it. And we have two type of tests in sCrypt. The first one is local unit testing, and the second one is testnet integration testing. So because any bug, any mistake in your smart contract may cause real economic losses. So we have two type of tests, and we are going to test our contract now. So let's start. So first thing we are going to do is let's say a sync the function, let me call the function main. Does it. So the first thing you will do when you want to test your contract is to compile the contract. The first thing you will do is to compile the contract, and you compile the contract by calling the compile function. You say await, then the name of the contract, demo. So this is my contract, and this is the file path. So I just press enter, so it is imported here. This is my contract, source contract, then the contract file name demo. So dot compile, this function will compile the contract into Bitcoin script. So the first thing you will do when testing a contract is to compile the contract. The contract. Then there is what we call a provider and a signer. So a provider is a standard Bitcoin node. It's a Bitcoin node that provides us with read and write access to the blockchain, while a signer is a private key which can be used to sign the messages. So a simple signer will be like a single private key, while a complex signer is a wallet. So for our test we are going to use a built-in wallet which is called test wallet. So let's say our signer const signer equals new test wallet. This is our test wallet. Let's import it. Then let me import my private key. Then provider, let me use since it is a local test, let me use do me provider, do me. So we have different type of providers. We have do me provider, default provider, sCrypt provider, tal provider, and many of them. So for this local test we are going to use this do me provider. So this is our provider. Yes, so that's it. Then our instance, our contract instance, let me show you something now. Let instance equal new, then our contract name. So the contract instance, let me show you here. In the contract, we have our constructor. So in the constructor, we initialize the value of x and y. So in the test file, our instance will be new, then our contract name demo. Then we are going to pass the value of x and y here. So if you look at the IntelliSense, this demo required the value of x and the value of y. So let me say the value of x to be 2 and the value of y to be 3. So since it is a big integer, it must have a suffix of n. So this is my instance. Yes. So what I will do now is to connect my instance to a signer. So I will await instance, my contract instance dot connect signer. This signer, this wallet signer. So now here I have compiled my contract. I have I have my signer, test wallet signer with Doomy provider, and I initialize. I get my contract instance here and pass in the values of the constructor. Then I connect my instance to a signer, so I can now test my contract. Let me say const transaction, which is let it be a call transaction. Then at input index usually is 0, then is equaled my contract instance here dot methods, then my public method. So for you to interact with the method here, after compiling the contract, creating a signer, getting the contract instance and connecting the instance to the signer, what you are going to do is to interact with the public method. Call the public method. So I'm now calling the public method. So what I will do, my contract instance dot methods is a function, then dot the name of my public method. I think the name is public, right? Is public. Yes, is the name of the public method. So I'll write is public. Here is it. Then here, let's go back to the contract. The public method here, I pass a value z. So z will be the product of a and b, and here in the test, the a and b is 2 and 3. Then the product of 2 and 3 will be what? 6, right? 6n. Then let me use a pack utxo from utxo, since it is a local text. We'll do me utxo. Then there is what we call method call options, but don't worry about it now. We will talk much about it later, then in our tutorials. So then method call options, then the name of your contract, demo. Yes. And since you have called the contract, you will say that let the result, since it will either succeed or fail, the result be equal to call transaction dot verify script verify. Let me call transaction dot verify script. Sorry, I'm having an error here, which is Okay, I'm coming. Let's make the call options. Oh, sorry. So I think I'll let result to be equal call transaction dot verify script then at input index. So what am I getting this error? Should be I didn't write await here. Sorry. So this is it, but let me I forgot to write await dot so verify script, yes, that's it, then at input index. So this is the result. It will verify the calling transaction whether it is succeed or fail. Then what I will expect, I'm expecting the result to return success or the result to give an error. Dot to equal true. Yes. So this is the function for testing our smart contract. So let me repeat it again. After you compile the contract, you create a signer, you get your contract instance, connect it to the signer, then call the public method and pass in the right argument. Then you verify the result. Then we use this to display it, described. Sorry, it is not correct. Describe test smart contract. Test smart contract. The smart contract name, let me call it demo, since it is demo. Then is sync then the contract must pass, then it should pass the public method and sync again. Then let me await the method, which is main. So we have finished writing the test for our contract, and if you have any question or you didn't understand something, you have to ask before I test it. I'm going to run it now. Do you have any question? Hello?
Yeah. Hello, sir.
Yeah, I can hear you.
Yes, sir. For all the codes that we have written, is this all part of the file that we have opened before, or we are just imputing these codes now for the first time?
So in our last class, we have write a contract, right? Are you around in our last class? Are you present?
Yes, sir.
So we have write a contract, and this is the file for our contract. And today we are testing our contract to see that whether it will work as expected or not. Since smart contract is a transaction with the blockchain, is interacting with the blockchain, so any transaction is it carries some financial something, maybe it consists of some money or some coins. So we want it to be in a way that there will be no any problem. So that's why we are testing the smart contract to see that it will work as expected. So after we write the contract, we are testing it locally here. So what we have did, we create a function main and compile the contract, create a signer. This signer will sign the message, and this provider will give us read and write access to the blockchain. And if you don't forget that in our contract we say that we are going to store two numbers on chain, which is x and y, and we are going to call the contract by providing the product of the number. So the numbers now are 2 and 3. These are our instances, and we connect the instance with the signer, and we call the public method by providing the correct product of 2 and 3, which is 6. Do you understand?
Yes, sir.
Okay, let's run it. So for us to run this the test, we will go to our terminal here. Alright, npm run test and hit enter. So it will compile the contract, get the contract instances, and take what we provided as the value of z, which is 6, and compare whether it is correct or not. If it is correct, it will pass. If it is wrong, it will not pass, it will fail, and give us the reason why it fails. So let us see it here. It is running. It is running. It is running. Just like let's give it some time. Yes. So this smart contract demo should pass the public method, and it passed the public method. So what happened here is that we test our contract that we have write in our previous class to see that whether the contract will work as expected or not. And what we have did is very simple. It's very simple. If the code is too long, let me do something that will make the code to be very little, so that instead of that line, let me delete that line and use do me signer, get do me signer. This is it. Yes, here. So this one too will work. Does it? So if you leave it like this, it will work. Let me save it and run it. So let me run it again. So let me do it in a way that it will not be too long, so that you will get it. So instead of that long cut, I reduce the line, and it is now running. Let me see. So it is running.
I think you need to repeat this explanation.
Okay. No.
Right from the beginning to end of the code, and explaining or pointing or mentioning the relationships between these test codes and our original source code of the
Okay, no
contract
problem.
we
You see, I have
created.
changed the signer to do me signer instead of that test wallet and that long thing that maybe confuse you. Write only do me signer function instead of that signer and whatsoever, and it also passed. So let me show you. Let me go from the beginning. This is our contract, and I hope all of you understand how we did it and what it does. So this contract literally just get two numbers, multiply them.
Together first, is the other members listening? Are you all together, please?
I think, let me,
Yes,
are we
yes,
together?
we are listening.
Present.
Okay.
We are
Let's continue. So if you understand the contract, let me just go to the test, since we have already did this in the previous class, and I think it is very simple and straightforward. We just get two numbers, multiply them, provide a product for them. If you get the product correct, then you can interact with the contract. Otherwise, you cannot interact with the contract. So here, if you come under the test directory, test, local test, you see this file that you need to write the test that we have written now. So forget about all this import. When you are working with it, you can import it automatically. So I write a sync function, and I call the function name main. So I know that some people will be confused about async, but if you are familiar with asynchronous programming language, async is very easy for you to understand. But if you don't understand, let me see how I will do. Async and await are features in programming languages that support asynchronous programming, specifically used in functions. So the importance of this is where some certain tasks may take some time to complete. For example, now you are connecting with the signer, you are connecting with the provider, and they are connecting you to the blockchain. So it is a task that may take some time. So this async and await, it will divide the work. Maybe you connect, you send a request to the signer, you send a request to the provider. So it will wait for them to resolve or reject that request before it continues, and it will do another work instead. So this is the importance of this async and await. You compile, you will await it to compile, and you connect with the signer, you will await it since it is a request. So this is the importance of this async and await. In this async function is like a promise that will return either resolved or rejected. Async, then await, you wait for it to compile, await, connect to the signer. This is it. Await to interact with the contract. That is it. So this is the await and async. So some people will be confused what is await and what is async. If you are not familiar with asynchronous programming, you will not know what is await and async.
Okay, excuse me, sir.
Yes, I can hear you.
I
Continue.
think the way you are taking it now, I'm following you, and I know a lot are following this way. As you are explaining it one after the other, I think it will really help, sir. I think I'm getting what you are doing now.
Thank you very much.
And then, from the files that we opened the last time, our last class, inside of it there are several files, like demo ts, which is the name of the file. Inside of it we have contract, we have test, and all of that. So where are you building this one that we are writing now? Which of these files that we are building this on?
Maybe you have come late, but before I started, I showed the structure of the pie of the contract of the project. So this is how it is, with all these files, with all these node models that you may need some to use some of the files in the node models, but not all. And under this source directory, there is contract folder where our contract is demo.ts, and this is the file. This is it. And under test, if you open test, if you expand it, you will see we have two type of tests. We have local and testnet. You understand? So under this local test, we have demo.test.ts, and this is it. Before it was empty. I just write the contract here right now. And also this one is for the test, a local test, and for the testnet there is also a file here, demo.ts. We are going to write our test for the testnet here. And the reason for testing the contract is to ensure that it is working as expected. So we have to test it and see that is it working as expected or not. If there is any bug, then we will debug it. I hope you understand now. So we are here. This is the file, demo.ts, and I compile it, and I get the instance through that. Let me show you the constructor here. We have two parameters, x and y. So these are the instances, the value of x and y. 2 and 3. I just write 2 and 3. So this is the instance. Then I connect my instance with a signer. With dummy signer, it is ideal for local tests. This dummy signer. Then after connecting my instance with the signer, I call my public method, and the name of the public method in the contract is what? This is the name, is public. So I await the instance that method. This method is a function that will take the public function name, and you must provide the value of z here. This is the value of z, sysn. Since in our contract we says that we are multiplying the value of x and y, and whoever provides the product of the x and y is one that can interact with the contract. So here in the test we say that the value of x and y is 2 and 3. Then the product of 2 and 3 is 6, because 2 times 3 is 6. So we provide 6 here so that we can interact with the contract. And this method call options is something on its own. We are going to explain it when we come to built-ins and some stuff like that. Don't worry about it now. Then this result will verify our input of z. Is it equal to the instance value? By following the assertion function to see that is it equal to the product. If yes, then it will return success. We are expecting success. Otherwise, we will get error. So this is the end of the function, and here we just test it with Mocha that it should pass this method, and we await the main function here. So since we test it with the correct parameter and it passed, let me change this 6 to like 4, which is wrong because 2 times 3 is not 4. But let's test it this way to see that will we get an error, and I'm sure that we will get an error. But let me stop here. If you have any question, please ask. Please ask a question.